So the derivative of 2 to the power of x of this function, let's see, this is a bit difficult. So, so this is what we want to compute. What is the derivative? What we see very often is the mistake that people do something like this. And this is unfortunately completely wrong. Why is this a problem? So don't mix it up with, you see, if 2 to the power of x is something very different than 2x to the power of 2. Yeah, so if you draw this, the exponential function looks something like this. And this is the quadratic function. This looks very different. This looks something like this. So here, indeed, the derivative is then 2 to the power of 2 minus 1 is then 2x. But here we are not allowed to do this. And what can we do in this case? Well, here's a little trick. What we could do is write this as 2 to the power of x is the same as e to the logarithm of 2 to the power of x. Why is that? Well, e to the logarithm, the natural logarithm, is actually not doing anything because I'm performing here a function and then again the inverse. So this is correct. But why am I doing this? Why is this helping me? Well, then I get e to the power of logarithm 2 to the power of x. This is equal to e. Then remember the rules for the logarithm. This comes in front here as a factor. X times logarithm of 2. And now the nice thing is, now I have an exponential function and I can just apply the chain rule here. So the chain rule, why the chain rule? Because this is a function of a function, so this is the so-called inner function, and then e to the power of is then the outer function. So if I compute this, I first compute x times logarithm of 2, and then on top of that, I take the result and put it in the exponent of e. So I can read this as a function of a function, apply the chain rule. So again, u of v of x. And if I take the derivative of this is again the chain rule times v dash of x. And in our case, the outer function u of v is just e to the power of v, and the inner function is just x times logarithm of 2. Logarithm of 2 is just a number. Okay, and then I get the outer derivative. And the nice thing is about the exponential function, its derivative, it's equal to its own derivative, so u dash is just also equal to e to the power of v. And what is the derivative of v? The derivative of v is just, what do I have here? Well, I just have a linear function here, so x times a number, a constant. So if I take the derivative of this would be just the constant. Okay, so I'm almost done. So then I apply here the chain rule, which would be u dash. This was this value here, so it's e to the power of v times v dash, and v dash is just the logarithm of 2. And I can simplify this and let e to the power of, what was v? V was this here. This is then x times logarithm 2 times logarithm 2, and I can write this back here as an exponent here, so then I get e to the power of logarithm 2 to the power of x times logarithm 2, and these are inverse functions, so this is just equal to 2 to the power of x times logarithm 2. So a long way to go, and indeed this was a difficult exercise, but now you know the trick. So our answer is that the derivative of 2 to the power of x is actually 2 to the power of x times logarithm 2. And again, don't make the mistake and mix this up with x to the power of 2. This is very different to 2 to the power of x.